In 1972, NASA tried to blow up the moon. Well, not really, but it sounds cool though, right? Instead, they crashed a rocket into it and listened. The funny thing is, that isn't the strangest thing about the moon. The deeper we study it, the more questions we find. Questions about its size, its origin, its relationship with Earth, and a coincidence so unlikely that some people still struggle to believe it's real. We see the moon almost every night. But what if the most familiar object in the night sky is actually one of the strangest? In November of 1969, astronauts aboard Apollo 12 left something behind on the moon, a scientific instrument called the seismometer. It has one job: to listen. If the moon was shaking, scientists wanted to know about it. You might think, well, what's exciting about that? And I honestly say nothing, unless you're planning to crash a rocket into the moon and then listen to seismic activity the crash would have caused. But who would want to do that? Well, NASA, and that's exactly what they did. They crashed the spent rocket stage into the moon. The impact wasn't small. The rocket hit the lunar surface at thousands of miles per hour, releasing energy equivalent to roughly a ton of TNT. Now, I'm not an expert, but a ton of anything sounds significantly big. Scientists expected the moon to shake, but they didn't expect just how long it would be shaking after. The vibrations continued and continued and continued some more. To people studying the data, the moon appeared to behave less like a solid rock and more like a giant bell that had just been struck. Almost immediately, the observations captured people's imagination and they started asking, was the moon hollow? Had scientists discovered something completely unexpected about its interior? Over the years, those questions would fuel countless conspiracy theories, but the real explanation is arguably even more fascinating. Unlike Earth, the moon is incredibly dry. Our planet contains water, active geology, and countless processes that absorb and dissipate energy. The moon doesn't. When seismic waves travel through the lunar interior, they can continue bouncing around for much longer before finally fading away. In other words, the moon wasn't literally ringing like a bell, but the comparison wasn't entirely wrong either. The moon was behaving differently than scientists expected, and that raises an interesting question. If Earth's closest neighbor could surprise scientists this much, what else might be hiding beneath its familiar surface? The experiment revealed something unusual about the moon's interior, but that's not the only thing that makes our natural satellite different. In fact, scientists noticed something strange about the moon long before they ever landed on it. It's simply too big. Not in an absolute sense, there are larger moons in the solar system. Jupiter's moon Ganymede is bigger, so is Saturn's moon Titan. The weird part is its size relative to Earth. Most planets are accompanied by tiny moons. Mars, for example, has two, Phobos and Deimos. Both look less like worlds and more like captured space rocks. If they disappeared tomorrow, Mars probably wouldn't notice. Earth's moon is different. It's enormous. Its diameter is roughly 1/4 that of Earth. To put that into perspective, if Earth were the size of a basketball, the moon would be about the size of a tennis ball. That's unusually large for a moon orbiting a planet our size. In fact, the Earth-Moon system is so unusual that some scientists have argued it behaves more like a double planet than a traditional planet and moon. And the oddities don't stop there. The moon doesn't just orbit Earth. Earth and the moon actually orbit a common center of gravity called the barycenter. Imagine two ice skaters spinning around each other while holding hands. One is larger than the other, but both are moving. That's much closer to what's really happening in the Earth-Moon system. For something we see almost every night, the moon is surprisingly unique. Astronomers have discovered thousands of worlds beyond our solar system. Yet even among all those discoveries, our moon remains unusual. And strangely enough, its size may be connected to another coincidence that seems almost impossible. A coincidence so precise that if it were even slightly different, one of nature's most spectacular events would never happen. Let me present a total solar eclipse. For a few brief moments, the moon perfectly covers the face of the sun. Not partially, not approximately, perfectly. Which shouldn't happen. The sun is about 400 times larger than the moon. At first glance, that sounds like the end of the story. A giant star and a relatively small moon. They shouldn't even look remotely similar in the night sky. And yet, they do. Because by an extraordinary coincidence, the sun is also about 400 times further away from Earth than the moon. The result? Both objects appear almost exactly the same size when viewed from Earth. Think about that for a moment. One star is nearly 1.4 million kilometers across. The other is a rocky world just over 3,400 kilometers wide. Yet from our perspective, they fit together almost perfectly. It's this cosmic coincidence that allows total solar eclipses to happen. And when they do, something remarkable becomes visible. The sun's corona, its outer atmosphere, a ghostly halo of superheated plasma extending millions of kilometers into space. Without the moon covering the sun's blinding surface, we would never see it with the naked eye. But the coincidence gets even stranger, because the moon is slowly moving away from Earth. Not enough to notice, only a few centimeters each year, but over millions of years that will start adding up. Hundreds of millions of years ago, the moon appeared much larger in the sky. Hundreds of millions of years in the future, it will appear too small to completely cover the sun. Total solar eclipses will disappear forever, which means that right now, in this tiny slice of cosmic time, we get to witness one of the most spectacular sights in the universe. A sight made possible by a coincidence so precise that it almost sounds made up. But as strange as the coincidence is, the moon's most important role may have nothing to do with eclipses at all. Because without the moon, you might not even be here to see one. For that, we need to imagine Earth without the moon. At first, it doesn't sound like a big deal. The moon disappears, the night sky gets darker. No more moonlight, no more eclipses, life goes on. Or does it? Because the moon does far more than simply orbit our planet. Its gravity constantly pulls on Earth. You see the most obvious effects every day in the form of ocean tides, but the moon's influence goes deeper than that. Earth spins like a giant top, and just like any spinning top, it can wobble. The difference is that Earth has something helping to stabilize that wobble. It's the moon. Its gravitational pull acts almost like a natural stabilizer, helping to keep Earth's axial tilt relatively steady over long periods of time. And that matters more than you think. Earth's tilt is responsible for our seasons. The angle at which sunlight reaches different parts of the planet changes throughout the year, creating the predictable cycle of spring, summer, autumn, and winter. And if that tilt began changing dramatically, the consequences could be severe. Some regions might experience extreme climate shifts. Weather patterns could become far more chaotic. Entire ecosystems would be forced to adapt to a planet that behaves very differently from the one we know today. People still debate exactly how dramatic those changes would be, but many believe the moon has played a major role in maintaining the long-term stability that complex life depends on, which leads to an incredible realization. The moon isn't just another object in the sky, it may have helped create the conditions that allowed life to thrive on Earth in the first place. For something that seems so ordinary, that's an extraordinary responsibility. But there is a problem. If the moon is this important, if it's this unusual, then where did it come from? And surprisingly, that's a question scientists are still trying to fully answer. After all, we've studied it for centuries, we've landed on it, we brought back hundreds of kilograms of lunar rock. Surely the mystery has been solved. Well, mostly, but not entirely. Today, the leading explanation is known as the giant impact hypothesis. According to this idea, the young Earth suffered a catastrophic collision more than 4 billion years ago. A Mars-sized world, often called Theia, slammed into our planet. The impact was unimaginably violent. Material was blasted into space, and over time that debris came together to form the moon. At first glance, the theory makes a lot of sense. It explains why the Earth and Moon are linked so closely. It explains the Moon's relatively small core, and it explains why our Moon is unusually large compared to Earth. For decades, this was the leading explanation, but then we started looking closer, and we found something unexpected. The Moon and Earth are remarkably similar, in some ways almost too similar. When researchers analyzed lunar rocks returned by the Apollo missions, they discovered chemical signatures that closely match those found on Earth. That's strange, because if the Moon formed largely from another world colliding with Earth, you might expect it to look more different. Instead, it often looks like it came from Earth itself. Over the years, scientists have proposed new versions of impact theory to explain this. Some suggest the collision was more violent than originally thought. Others propose the Earth and Theia may have mixed together more completely than expected, and many researchers believe the answer lies somewhere within those evolving models. But here is the important point. The mystery isn't fully closed, and while researchers continue searching for answers, the Moon keeps reminding us that even our closest celestial neighbor still holds secrets. But perhaps the strangest secret isn't how the Moon formed. It's just how perfectly formed it appears to be. At first glance, that might sound ridiculous. Of course, the moon is round. Most large objects in space are as well. Gravity naturally pulls material towards the center, creating a sphere. Case closed. Except the moon isn't just round. It's remarkably round. In fact, compared to its size, the moon is one of the most spherical objects in the solar system. Its shape deviates surprisingly little from a perfect sphere. That's impressive when you consider what the moon has been through. For more than 4 billion years, it has endured countless asteroid impacts. Some large enough to carve out craters hundreds of kilometers across, others powerful enough to reshape entire regions of its surface. Yet despite all the punishment, the moon remains uniform. Scientists believe this tells us something important about its past. Billions of years ago, the moon was a very different place. Instead of the cold, lifeless world we see today, much of its surface may have been covered by a vast ocean of molten rock. As that ocean slowly cooled and solidified, gravity helped shape the moon into almost perfect sphere we see today. In a way, the moon's shape is a fossil, a snapshot preserved from a time when the solar system was still young and violent. And that might be the most important clue of all, because while Earth spent billions of years rewriting its history, the moon has spent billions of years preserving it. The moon is the most familiar object in the night sky, yet it's also one of the strangest. It rang like a bell, it creates perfect eclipses, it may be one of the reasons we are here, and even after centuries of study, it still holds secrets. For something we see in the sky for our entire lives, that's pretty remarkable. Thank you for watching, and as always, keep looking up.